Okay. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Aiman bin Muhammad Abdasir. Matric number CE200089. And now I will do the demo for the lab activity 1. Okay. First, we'll need to do the program name, which we will do lab 1 underscore lab LA1. Okay, then base will do 100, and then add. Okay, next we will do the instruction part. Okay, the first instruction we will do the move. Okay, first we will do the move instruction, where we will move number 5 to R00. Okay, new instruction. Okay, at the CPU instruction in memory tab, we will have the instruction. Okay, then we will double click to execute the operation. Okay, from the general purpose CPU register, we can see that the R00 value will be 5. This is because we move the value 5 to the R00 register. Okay, next we will do move instruction also, but we will move number 8 to register R01. Okay, number 8, move 8 R001, new instruction. And then we at the CPU instruction tab, we have the move #8 R01, which double click to execute it, and we can see at the register R01, the value will be 8. Okay, next we will do the add instruction. Add instruction is at the arithmetic tab. Okay, first we will need to add content of R00 and R01. Okay, R00, the source will be R00 and the destination will be R01. New instruction. Okay, the instruction will appear at the CPU instruction tab. Double click to execute it, and at the general purpose CPU tab, we will see the value of R01 will become 13. This is because the value of R00, which is 5, plus add will plus with the value of R01, which is 8, and then value of R01 will become 13. Okay, then we will do the push instruction. The push instruction will be at the data transfer PSH. Okay, we will need to push the above value, which is the value of R01, to the top of the hardware stack. Okay, we will push the value in the register R01, new instruction. Okay, double tap to execute it, and we can see at the program stack, the value of R01 have been pushed to the program stack, value 13. Okay, then we will also do the push instruction, but we will push value -2 to the top of the stack. -2. Okay, new instruction. Double click to run it, and we can see the value of -2 have been pushed to the top of the program stack. Okay, next we will do the next we will observe the value in the SP register. In the SP register, uh, when we push a value, when we do the push operation, instruction, the value in the SP register will be updated, which we can see the value has been changed. Okay, next we will create a new instruction which we will compare the value of R00 and R01. Okay, that is new instruction, and then compare. We will compare the value of R00 and R01. Okay, we will then double click the instruction to execute the operation. Okay, we will now observe the special CPU register tab. At this part, the operation CMP R01 and R02 has appeared, and then at the SR status flag, there are OV, Z, and N. OV is overflow, Z is 0, N is negative. There are no value because the value of R01, which is the destination, is greater than the base, which is R001, R00. Okay. Next, we will do the jump instruction, which we will unconditionally jump to the first instruction. Jump. Okay, we will jump 0. Okay. When we execute the operation, the arrow will now pointing at the first instruction. This happened because the operation will now change to the first instruction, which means the next instruction that will be executed is at the arrow point, at the place where the arrow pointing at. Okay, next we will differentiate the P-add and L-add. P-add is the physical address, which is the address in the real memory, while L-add is the logical address, which is the address the CPU use. Okay. Okay, next we will do the pop instruction. Pop, which we will pop the value from the program stack to the register R02. Okay, we will pop R0 first. Okay, we will pop R02. Okay, when we run execute the operation, we can see that the value of -2, which at the top of the program stack, have popped to the R02 value. Okay. Next, we will also do the pop instruction, which we will pop the value at the program stack to the R03. New instruction. Okay, double click to execute, and we can see the value from the program stack have now go to the R03 value. Okay. Next, we will execute the operation one more time to see what will happen. An error will appear because the program stack is empty. Okay, next we will do the compare instruction, which we will compare the value of R04 and R05. Okay, when we run the operation, when we observe the special CPU register at the SR status flag, we can see that there was a tick at the Z part. This is because the value is 0. Since R04 and R05 is both 0, when we compare the operation, the value is 0. Okay. Next, we will need to insert two equal value in the register R04 and R05 and execute the instruction. Okay, R04, we use the register value to change the value of the register. Okay, R04 we will change to 5, and then R05 will also change to 5. Okay, next we will execute the compare instruction. Okay, when we execute the operation, we can see at the SR status flag that the Z status bar is tick. This is because both value is the same, so when 5 minus 5, it will become 0. Okay, next we will insert the value in R05 will be greater than R04. Okay, since R04 will be 5, we will change the R05 to 8. And then we will execute the compression. Okay, as you can see, there are no tick at the SR status flag. This is because the value of R05 is greater than the value of R04, which means there are positive value. Okay, next we will change the value of R04 will be greater than R05. Since R05 is 8, we will change the R04 to 10. Okay, then we will execute the same instruction. Okay, at the special CPU register, we can see that the negative status flag is ticked. This is because the value of R04 is greater than R05, which means when the destination minus with the base, there will be a negative value. Okay, next we will create instruction which will jump to the first instruction if the value registered in R04 and R05 are equal. Okay, we will do a new instruction, JAQ, jump if equal, which will jump when both value of R04 is the same as R05. JQ 0. Okay, let's change the value of R04 to 8, which is the same as the value of R05. Okay, since we have changed the value of R04 and R05 to the same, we will now do the compare operation to see will the instruction jump to the first instruction. Okay, click. Yeah. Okay, at the CPU instruction tab, we can see that the arrow has jumped to the first instruction when both value of R04 and R05 is the same. Okay, next we will do the subtraction instruction at the arithmetic part, which we will subtract the value contained in R04 and R05. Okay, we will do the subtract instruction. We will subtract the value of R04 and R05 if condition in the previous instruction is not met. Okay, execute the instruction that compare the content of R04 and R05. Okay, we already have the compare R04 and R05 and JAQ. Okay, JAQ will jump to the first instruction if if the value of the R04 and R05 is equal. So we will change the value at the R04 and R05 to make it not the same. Change the value R04 to 5. Okay. Since the value is not the same, we will now do the compare operation. Okay, since this is not the same value, the operation jump will not occur, and then it will proceed to the next instruction. Okay, then we will run the subtract instruction. Okay, as we can see, the value of R05 has changed to 3. This is because we have the subtraction operation has occurred, which is R05 is 8 minus with the R04 5, which will become 3. The result is stored at the R05. Okay, then we will save the instruction by clicking the save button. Okay, that's all from me. Thank you, doctor.